In this video, we'll be going through indeterminate forms of the type infinity by infinity, while previously in limits L4 we had already gone through indeterminate forms of the type 0 by 0, which were solvable by L'Hopital rule. Now, if limit x tends to a fx over gx is an indeterminate form of the type infinity over infinity such that fx and gx are both differentiable, then by L'Hopital's rule, limit x tends to a, limit x approaches to a, f of x divided by g of x equals limit x approaches to a, f prime of x divided by g prime of x, or we can say derivative of the numerator divided by derivative of the denominator, as we have already seen in the previous video. Also note that in most of the forms of the type infinity by infinity, we often convert infinity by infinity form into 0 by 0 form by some suitable manipulations to avoid the long and tedious calculations. As an example, if we have to compute the limiting value of limit x tends to infinity x squared plus 3x plus 5 divided by x squared minus 7x plus 6. So first of all, we will check whether this is an indeterminate form or not of the type infinity by infinity. So x infinity ko ja raha hai, so infinity square plus 3 into infinity plus 5, so overall upper numerator it will be infinity divided by denominator will be infinity as well. So this is an indeterminate form of the type infinity by infinity. So therefore we can solve this, we can find its limiting value by L'Hopital's rule. So therefore applying L'Hopital's rule, so this will be limit x tends to infinity x square की differentiation derivative of the numerator divided by derivative of the denominator, x square की differentiation 2x plus 3 into x, so it will be 3 divided by x square की differentiation फिर से 2x minus 7. So again we can note that this is again infinity by infinity form, thus we can again apply L'Hopital's rule. Thus it will be limit x tends to infinity ऊपर फिर से numerator की differentiation divided by the differentiation of the denominator, so 2x की differentiation it will be 2 divided by 2 which will be 1, so that means इसका limiting value 1 होगा. Again, next example will be limit x tends to 0 from the right log of sine ax divided by log of sine bx, where a and b are both positive. Since log of negative numbers is undefined, so this limit log x approaches to 0 from the right makes sense because log of negative numbers is not defined. Again we have log of 0 is also undefined. Log 0 is undefined, or we can at the same time write log of 0 is infinity. Thus we can write, so when x approach to 0 from the right, so this will be log of sine 0 is 0, so it will be log of 0, log 0 is undefined, or नीचे be infinity, so we will obtain infinity by infinity form. So this is an indeterminate form of the type infinity by infinity. Thus by L'Hopital's rule, limiting value will be the derivative of the numerator divided by derivative of the denominator, so it will be limit x tends to 0 from the right, so log of sine ax की differentiation, we know differentiation of log x is 1 by x, so differentiation of log x is 1 by x, so as such differentiation of log of sine x will be 1 divided by sine of ax, फिर sine of ax की differentiation as functions of function say cos of ax into x की internal differentiation, that will be a, divided by log of sine bx की differentiation, so it will be 1 divided by sine bx की differentiation by function of function say cos of bx into b, which will be a बाहर आएगा और b a by b बाहर आएगा, so it will be a divided by b, limit x approaches to 0 from the right, so it will be cos of ax divided by sine ax whole divided by cos of bx divided by sine of bx, which will be a divided by b, limit x approaches to 0 from the right, so cos ax divided by sine ax, it will be cot of ax divided by cot of bx, सो cot bx का फिर से अगर 0 वैल्यू दे देन इन दैट केस इट विल बी अगेन इन्फिनिटी बाय इन्फिनिटी फॉर्म। और इन्फिनिटी बाय इन्फिनिटी फॉर्म को अगर हम फिर से पाई लॉपिटल्स रूल सॉल्व करें then we will again obtain infinity by infinity form. Thus this calculation will get a bit tedious or long. So in order to avoid this, at this stage we will convert the infinity by infinity form into 0 by 0 form by some suitable manipulations. So if we write, so this will be a divided by b limit x tends to 0 from the right. Cot ax को 10 में convert करेंगे, so it will be 1 divided by 10 of ax divided by 1 divided by 10 of bx. Thus this will be a divided by b limit x approaches to 0 from the right by reciprocal. So we can write this as 10 bx divided by 10 of bx. अगर हम अब check करें, so it will be when x approach to 0, so 10 0 will be 0 divided by 0. Now this has been reduced to 0 by 0 form. 0 by 0 form. Thus we can again apply L'Hopital's rule. So this will be a divided by b limit x approaches to 0 from the right. So 10 bx की differentiation, 10 की differentiation sec square bx into b की internal differentiation, that will be b divided by 10 ax की internal 10 ax की differentiation, so it will be sec square ax into a, which will be equal to a divided by b into b divided by a फिर से बाहर आएगा, so it will be b divided by a into limit x approach to 0 from the right, so it will be sec square bx divided by sec square ax. So b से b और a से a कट जाएगा, so it will be limit x approach to 0 from the right, so it will be sec bx divided by sec ax whole square, which by property of the limits equals limit x approach to 0 from the right, so it will be sec bx divided by sec of ax whole square, so it will be sec bx divided by sec ax, which means it will be 1 divided by 1 whole square, so which will be 1. So next example is limit x tends to 0 from the right, log of sine x to the base x, and by change of base formula we have log of b to the base a equals log of b divided by log of b. Obviously it is understood that we are taking e as the base here, e and e as base. Now by change of base formula, this will be equal to limit x approaches to 0 from the right, so it will be log of sine x divided by log of x. Again when x approach to 0, so sine 0 will be 0, so log 0, again infinity, so log of 0 infinity, so this is infinity by infinity form. So therefore by L'Hopital's rule, its limiting value will be limit x approaches to 0 from the right, so differentiation of the numerator divided by the derivative of the denominator. So log of sine x की differentiation फिर से 1 by sine x into sine x की internal differentiation, so that will be cos x divided by log x की differentiation 1 by x. So it will be limit x approaches to 0 from the right, so it will be cos x divided by sine x into x divided by 1 reciprocal x divided by 1, which will be limit x approaches to 0 from the right, x cos of x divided by sine x. Now we'll again check whether this is an indeterminate form of the type infinity by infinity or 0 by 0. So x cos of x, so x is going to 0, so this will be 0, sine 0 is 0, so this is reduced to 0 by 0 form now. So therefore we can again apply L'Hopital's rule, which means we'll be differentiating numerator and denominator separately. So this will be limit x approaches to 0 from the right, x cos x की differentiation product rule से, so x will be left over, so sin x cos x की differentiation minus sin x plus cos x as it is into differentiation of x, which will be 1 divided by sin x की differentiation cos of x. Now we can use a limiting value, so it will be 0 into minus sine of 0 plus cos of 0 divided by cos of 0. So 0 plus cos of 0, so this will be 1 divided by 1. Again, its limiting value will be 1. So the next example is limit x tends to 0 log of x square divided by cot of x square. This square is the exponent of x only, not the exponent of log of x. So again, this is an indeterminate form of the type infinity by infinity. So this is an infinity by infinity form. So therefore again apply L'Hopital's rule. So by L'Hopital's rule, this will be limit x approaches to 0, so log of x square की differentiation 1 divided by x square into x square की differentiation by function of function, as this will be 2x divided by cot of x की differentiation minus cos x square x square into x square की differentiation into x square की differentiation 2x. So 2x से ये 2x कट जाएगा, so it will be limit x tends to 0. So it will be 1 divided by x square into 1 divided by minus cos x square into x square. This will be equal to minus limit x tends to 0 1 divided by x square. So cosec is reciprocal of sine, so it will be sine square x square, x square. Or we can write this as minus limit x approach to 0 sine x square whole square divided by x square. Thus this is again reduced to 0 by 0 form. Thus limiting value will be the derivative of the numerator divided by derivative of the denominator. So it will be 2y sine x square into cos of x square into x square की differentiation 2x internal differentiation x square की differentiation 2x से 2x फिर से कट जाएगा. So it will be minus limit x approach to 0 2y sine of x square into cos of x square. अब हम limiting value use कर सकते हैं because indeterminate form has been avoided. So it will be 2 into sine of 0 square into cos of 0 square, so it will be 0.